Okay, today we are going to look at our final transformation in our unit, and we are going to look at dilations, but we're not going to necessarily be on a coordinate plane today. Up until this point, you've done a lot of work on the coordinate plane. So today we're going to take a step back, and actually when we look at dilations, it's going to be more about using similarity basically to enlarge or reduce an object. So we're going to start out real basic. These first four examples, you're simply deciding if it is a dilation or not. If it's not a dilation, let's state which transformation we think it is. So when we look at this first one here, it does appear to be going from a larger object to a smaller object, but it's not going to be a dilation because it's not proportional. For example, this side became a lot smaller, but this side became larger. See what I mean? It has to be proportional. So I'm going to say no, and in fact, this really does not represent any of the other types we've looked at. Letter B here, yes, this does look like a dilation. It has simply been enlarged. It looks like a right triangle, and this does look like a right triangle. Letter C, pentagon to pentagon, yes. Everything looks proportional. The angles all look the same. Side lengths look proportional. D is not a dilation, and in fact, we can't link it to anything else, but it has gone from what looks like to be an isosceles triangle to where these particular angles here are very different. So they have to have the same angles as we've talked about before. Okay, the next couple of examples deal more with a reduction or an enlargement, kind of some problem solving. On a sketch of a flower, 4 inches represents 1 inch on the actual flower. If the flower has a 3-inch diameter in the sketch, find the diameter on the actual. So I'm going to set up a proportion here by setting two ratios equal to each other. And the order I'm going to set it up in is how it is presented in the problem. On a sketch of a flower, so I'm going to put the information about the sketch here. On a sketch, 4 inches represents 1 inch on the actual flower. So sketch in the numerator, actual denominator. If the flower has a 3-inch diameter in the sketch, so my 3 will go in the sketch portion, find the actual. So from here, this setting up a proportion allows me to cross multiply. So when I do that, I'm going to have 4x equals 3, and when I divide by 4, I get either, you can leave it as 3/4, or that's the same as 0.75. So find the diameter of the actual flower, so 0.75 inches. Now, you might have looked at this example and you might have immediately said, well, all I got to do is divide by 4, which in the end is what I did. So you may not need a proportion to set these up. You might be able to quickly go from one model to the other. Okay, number 3. Actually, why don't you go ahead and try number 3? So if you want to pause the video here, try to set up number 3, and then I'll come back and go through both of these with you. So go ahead and pause the video right now. Okay, one thing you could do to get yourself started is you could draw pictures. So an artist is creating a large painting from a photograph divided into squares. So I'm going to start with a square here, and each square by a factor of 4. If the photograph is 20 centimeters by 25, so I'm just going to start by doing 20 by 25, what is the perimeter of the painting? So the painting is becoming larger by a factor of 4. So I'm going to have to multiply each of these by 4. So that would be 100, oh not 100, sorry, that would be 80 and then 100 over here. So if I have my new dimensions here, if this is my painting, what is the perimeter of my painting? Well, now I have 2 sides that are 100 plus 2 sides that are 80. So that's going to be 200 plus 160. So that's going to be 360. And so my perimeter is equal to 360, and I'm dealing with centimeters. So I'll add my label. Okay, so you may not have needed a picture. You might have looked at that and said, well, I'm just going to multiply by 4. What if the photograph is a square with side lengths of 10? So my photograph is going to be my square with side length 10. Find the area of the painting. Well, the painting is still going to be a factor of 4. So my side lengths become 40, and when I do area, I am doing 40 times 40. So the area of the painting will be 1,600, this time inches squared, because our area is going to be inches squared. Okay, before we do this next example here, I want you to get this handout, which hopefully the sub gave you. If not, if you would go ahead and grab that from her. I want to talk about a special kind of dilation, but I want you to work with one first. And I think once you actually work with one, you'll understand real quickly what the effect is. So we know what a dilation is. We're going to explore a dilation where the scale factor is negative. So up until this point, we have said the dilation factor is like a 3 or maybe a third. But let's talk about when it's a negative. So what I'd like to do with this one, we want to write the coordinates of P, Q, and R over to the side. And it didn't copy very well, but this section, this line right here along the triangle is 1 unit. This is 2 units. This is 3, 4, 5 units. So you can kind of see the dotted lines probably at every second unit, but you might do this real quick so that you can quickly count the coordinates. So P is at -2, +2, -2, +2. Q is at -1, 2, and R looks like it's at -1, -1. Okay, so those are the coordinates of those three. P prime, Q prime, and R prime are the images of P, Q, and R under a dilation centered at the origin with a scale factor of -2. Okay, so we haven't worked with negatives. Let's go ahead and just multiply all 6 numbers by -2 so we can get our coordinates. And then I want to graph it, and I want you to see what the effect is. So P prime, if I multiply -2 here in the ordered pair by the scale factor, I get +4. And I multiply 2 times -2, I get -4. So finish those other two out, Q prime and R prime. Okay, so you should have found 2, -4, 2, 2. So let's graph it. 4, -4. 1, 2, 3, 4. 1, 2, 3, 4. That's P prime. Q prime is at 2, -4. 1, 2, 3, 4. Q prime. R is at 2, 2. 1, 2, 1, 2. R prime. So let's connect. Okay, so 2 things I want you to notice. The size. It became larger, which is due to the fact that it is a 2. It's twice as big. But the orientation is very different. And in fact, if you look at from R, if we look at R up to R prime, it's going directly across the coordinate plane. Q down to Q prime, it's going across. P to P prime. And if you remember going back to rotations, that's a 180-degree rotation. So the effect of a negative scale factor is twofold. Number one, it does make it bigger or smaller by the value of the number, but it also does a 180 rotation. So I'm just going to write here a 180-degree rotation along with reduction or enlargement. So a lot of times we can multiply our values together, but oftentimes you'll see that it does make this difference. So let's go back to our notes. And in fact, what I have here at the top is simply what we just went through. If the scale factor of a dilation is negative, the preimage is rotated by 180 degrees. For k greater than 0, a dilation with a scale factor of negative k is equivalent to the composition of a dilation with scale factor of k that is rotated 180. So for our purposes, if you can understand the rotation and the reduction or enlargement. So number 4 here, draw the image of the triangle with the 3 vertices under a dilation with scale factor of negative 1/2. So let's first plot it, and then we'll do our ordered pairs and we'll replot it and look at it. So negative 4, positive 4, P, negative 2, negative 2, Q, and then 4, 0. Okay, so double check your triangle matches mine. I'm going to go ahead and multiply to get the 3 ordered pairs. So I'm going to take, well, there's 2 ways to think of it. The negative will simply change the sign, and then you're just dividing everything by 2. So negative 4 times negative 1/2 will end up being a positive 2. Positive 4 divided times negative 1/2 will give me a negative 2. Q, I will end here with a 1, comma, 1. And R will give me a negative 2, and then of course 0. So I'm going to plot this in pencil to see the difference. So 2, negative 2 is P prime, 1, 1 is Q prime, and then negative 2, 0. Now, the graph does not, it looks a little odd, but let's look point to point. First of all, I expected it to get smaller because I'm dealing with a half. And if I go from point P, P prime is across to the opposite quadrant. Q to Q prime are on opposite quadrants. R to R prime are opposite quadrants. So I do see my 180 rotation. Okay, I'm going to skip this last example. Let me go ahead and write your assignment here. You are going to be out of the book today, so you're going to be on page 653. I'm going to have you look at numbers 14 through 40 evens, but let's skip a couple of them. I want you to skip number 18 and number 28.